we have this satellite that revolve around the Earth. Now, from Newton's law of motion, that in space there is always an attraction between the mass of the satellite and the mass of the Earth. There's always an attraction between the mass of two bodies, and there's a radius between them, and this is the force of attraction between the Earth and the satellite. How? From Newton's law of motion, how then can we derive the relationship between G, big G, and small g? Let's assume this satellite has a weight that is equal to mg, that is exerted towards the Earth. And we know that the gravitational constant g between the mass of the Earth and the mass of the satellite is given as gm, mass of the Earth, mass of the satellite, over their square root, that is gravitational force, as derived. So from this we can say that let the weight of the satellite be equal to the gravitational force. So the weight becomes mg, the weight of satellite becomes mg, equal to g, mass of the Earth, mass of the satellite, over the square root of the distance between them. Now we are going to cross multiply. On cross multiply, we are going to be having mg square root arrow raised to power 2 equal to g, mass of satellite of Earth, and mass of satellite. Now if you discover we have the mass of the satellite here, we also have the mass of the satellite here. So we can easily cancel out the mass of the satellite. And on doing this, we can cancel this out and cancel this out. We are now left with the GR square equal to GM, mass of the Earth, and because we want to look for the mass of the Earth, this is the relationship that join big G and small g. But how do we find the mass of the Earth? We have to divide through by g. And dividing through by g, we're going to be having the mass of the Earth giving us g arrow square. Don't forget, this arrow is coming from the radius of the Earth, okay, which we deduce from the weight divided by g. From there, we can now plug in our values and we can then find the mass of Earth. Let's do that. So when we plug in the values, we have mass of the Earth as, and we know that g is 10 multiplied by the radius of the Earth is already a constant, 6.4 multiplied by 10 power 6 divided by the gravitational constant, which is giving us, we have to square this because there is a square on it, and there's g is giving us 6.67 multiplied by 10 power negative 11. Now we have to open the bracket, and we're going to be having 10 multiplied by 6.4 square, which is going to give us, if you press your calculator, 6.4 square. Let's take it gradually. So we get 6.4 square, which is going to give us 40.96 multiplied by 2 times 6 the power, 2 multiplied by the power, which is going to give us 10 power 12, divided all through by 6.67 multiplied by 10 power negative 11. On multiplying 10 by 40.96, we get 409.6 multiplied by power 12, 10 power 12 over 6.67 multiplied by 10 power negative 11. Now we cross to this other side. Let's make use of this side. Now what are we going to do? We are going to be dividing 409.6 by 6.67. On doing that, we are going to be having 61.4 power 10 raised to the power 12 divided by 10 to the power negative 11. Now, if you could remember the rule of indices and say a raised to the power x divided by a raised to the power y is going to give us a raised to the power x minus y. We apply this rule here. Since we have 61.4 multiplied by 10 power 12 divided by 10 power 11, we're going to be, 61.4. So we're going to be having 61.4 multiplied by power 12 minus 11. And opening this bracket, we're going to be having 61.4 power 12. A negative sign multiplied by a negative sign is going to give us a positive sign of this. And our final answer will be this: 61.4 multiplied by 10 power 23 kilogram, which is the mass of the Earth. If this video is helpful, please subscribe and also like. Do me a favor by subscribing. I'll really appreciate it. God bless you.